Ammonium formate and formic acid mediated catalytic hydrogen transfer reactions are often a convenient laboratory alternative to the standard method using hydrogen gas under pressure, and the simple apparatus for this process is shown here. However, certain precautions must be taken because the addition of dry catalyst to either formic acid or ammonium formate can result in rapid hydrogen production with the resultant risk of fire. Before starting such an experiment, ensure that the fume cupboard is free of clutter, that there are no flammable solvents nearby, and that a suitable fire extinguisher is available. The substrate to be hydrogenated is first dissolved in the chosen solvent. Replacement of methanol, which is a solvent often used in the literature, with the less volatile ethanol or propanol will lessen the fire risk. A multi-neck flask equipped with stirrer and air condenser should be used and placed under an inert atmosphere such as that provided by the vacuum manifold. The apparatus can now be evacuated by turning the tap on the manifold as shown, and this causes a small amount of bubbling of the solvent in the flask. When the tap is turned back, a blanket of nitrogen is created in the apparatus. This process is usually repeated a couple of times. The next step is to add the catalyst, and this is added portion-wise. Ice cooling of the solution during the addition of the catalyst is sometimes recommended. Next, the formic acid or ammonium formate as shown here is added portion-wise. As the reaction is sometimes exothermic, this method in which the formate is added last gives some control over the reaction. Again, an ice bath should also be available as a further precaution. Transfer hydrogenation should be conducted at ambient temperature if possible, since the heated reactions involving ammonium formate may produce sublimates of carbonate salts which can block the condenser. It's recommended that water condensers which encourage this sublimation are substituted with air condensers of as wide a bore as practical. Also, nitrogen manifolds with their narrow glass joints are unsuitable. If a reaction has initially been set up using such a manifold, simply removing a connection at the top of the condenser and placing an inverted funnel of nitrogen should give a sufficient blanket of the inert gas.